Yes. Finally a new video by Decodes.
Hello guys, well I'm as excited as you are for our second video, and today we are going to discuss about decision tree classification algorithm. Well, I stressed on the word classification, you'll soon know why. Well, first, before getting into that algorithm, we have to know about what is the difference between a classification and regression. Well, in classification, what we do is we classify the object into its class. Like, I have a stone, I have milk, and how do I classify it? Dairy product and non-dairy product. Well, milk, obviously the milk is a dairy product and stone is not. So what we did here, we already know the classes, name of the classes to which it had to be predicted, dairy and non-dairy. We took it, we compared it, we checked it, and we put it in their respective class. Now, what is regression then? Okay, we learn from the previous values, that is the trained values. Like for in a stock market prediction itself, if there is a bank, okay, well, let's name an X bank. What these values of the X bank will be learned, how in history it did, how many ups and how many downs, bears and bulls, how much had happened. Then if we give in the input, what will it be tomorrow, what will be the price of this X bank tomorrow, it will give me a value, maybe profit or maybe loss or maybe the amount or what is the price it's going to be. That was not already saved, that it predicted through a certain mathematical algorithm. That is a regression. In classification, it does not predict any values, it just tells you in what class or in what type of data it is. So today we are going to learn about decision tree classifier, because there exists decision tree regressor, and we are not going to discuss that today because today's subject is about classification. Okay, so what is the data set we have today? How do we upload a data set? Yes, we upload to session storage, we upload the, yep, okay. So here we can see I have a dataset iris.csv. Okay, what is this iris.csv? Let's check. So we have sepal length, sepal width, petal width, and iris set to sub. Maybe I don't know. I'm not a biology student. Well, not only that, okay, there is different species of it and different values for each and every species, varying very much. Like it was 4.4 here, it was 1.6 here. Okay, Setosa, versicolor, virginica, and maybe that's it. Who knows? Well, let's check. Oh yeah, maybe that's it. So we saw our data set and we are familiar with it. Now we know that each type of species like Setosa, versicle or whatever it was, it has different types of features dependent on it, like sepal length and sepal width, petal length and petal width. So we have to identify, oh, okay, we'll discuss it in that code, how we are going to identify it. So I'll run this, importing pandas and datasets scikit-learn, because we have to classify it into this. This is a normal data set and this is y. What is this y? Okay, we need a dependent variable. What are our independent variable? We have many independent variables here, that is, sorry, sepal length, sepal width, petal length, petal width. These are our independent variables because they are not dependent on anything, and whatever it is already there. And since we are going to make a decision, we need to give a dependent variable as well as independent variable, right? So for dependent variable, what we give is iris.target. Here it is, yes. So what does dot target function do? Dot target function runs through our data set, checks for comparison for, like this first one, it may have took sepal length, sepal width, petal length and petal width and given it a random value 0. As such, it has given most of it 0, most of it 1 and then 2. Okay, it gives it completely randomly and it depends on its features being x1, x2, x3 and x4, sepal length, width, petal length and width. Okay, so let's train our model, fit our model into it. Decision tree classifier created. We should not do the mistake here. As I mentioned earlier, there is something called decision tree regressor also, but we are using classifier here. What is pi dot plus? Pi dot plus is used when we have to create graphs and take output as you'll see as in the form of nicely scripted data. And graph wizard is to draw graph, obviously. And then okay, so we have first used imported string IO. What is string IO? String IO is getting output or input in a string format. IPython.display we have imported image. What's in image? Image is used when we have to get the output in an image format. That here we have we need the decision tree graph in .png format. Then we have scikit-learn.tree import export graph wizard. Export graph wizard is a class which is mostly used in decision tree itself to check how the features are classified. We will learn from its sheet and scikit-learn. I'll explain it to you more further in the video itself. And import pi.plus, as we have installed it above, we had imported it down here. Okay, so string.I input output, we have given it to dot data frame. What is dot? Okay, dot data we will also discuss in that sheet itself, scikit-learns. Export graph wizard, yes, here it is. What is export graph wizard? Okay, first of all, export a decision tree in dot format. This function generates a graph wizard representation of the decision tree. That is why we have string.io in dot data format. Now we have D tree. What is this D tree? That is the decision tree. Out file is equal to none. Out file is the return value of your function. Here it is given none, but here we have used dot data. Dot data return value is used when we want our output in .png format, right? And max depth is the total depth of the graph. We know for a tree we have root, node, and that is how we get the depth. Feature names is the feature that is available. Here we have features x1, x2, x3, x4, petal length, width, and sepal length and width. Yeah. Class names, okay. What else we have named here? We have feature names. We have filled is equal to true. What is filled? Okay. In this graph, you can see that some of these hues are darker than the others. More the darker, more the probability of the values being classified into it is correct. More the correct, the darker the hue. That is how it is checked. And then we have rounded is nothing to get a good rounded curve. That's it. The box and the format name is we'll get it here. It is Helvetica fonts instead of Times New Roman. Yeah, that's it. Okay, so now since the graph is extracted into pi.plus as graph from .data format, and it is, as we have imported image here, we got the output in PNG format. Well, now I'll explain it how this actually works. You can see in the first class it is petal width less than 0.8. It's completely white color. The color itself means that everything can fall under it and everything can be classified under it. That is what it means. Okay, now Gini is 0.667. Gini, what is Gini? Gini is the probability of a data being predicted in that class being wrong. That is, there is 66%, 0.667, that is 66% chance that value being predicted in this class can be wrong. And how many samples will be included? 150. our total data set includes 150 values, that is, so it is correct. And then value is 50 50 50, that is 50 falls in the left arm, other 50 50 falls in the right arm. 50 0 0 because these two 50s, that is these two, went here. And your Gini is 0.00. Why 0.00? What was Gini? Gini was the probability of being wrong. Anything that falls in this orange darker hue, it will be correct. That is what it's showing. It will be correct. If this condition is false and petal width is also less than 1.75, we have Gini 0.5, that is 50% chance if that value falls in that, it is going to be correct or it can be wrong. And how many values we have for that? We have total 100 values, out of which 50 50 it is divided, where here it is 49 5, so 1 here is remaining from 50, which will come here, 55 45 here, right? In this way our total graph is divided. And one more thing to look in this graph is that we have every every terminal node will have Gini 0.0. Why is that? Because since the decision tree has ended, the terminal node will have 0 because there is no other classification for a value to be classified, and it has to fall under that class itself. That is why that is the probability of anything happening other than these terminal nodes is 0. It has to be correct and it has to fall under that class. So that is it. 47 values can fall into this terminal node, 1 value can fall into this, 3 into this, 2 1 1 2 values in these all. So that is what decision tree is all about. We get a value, we train our model, we get an input from our user, and we check if this falls in this category. That is what this decision tree classifier is used for. Well, I hope you guys understood, and I hope you guys really understood that this dot target function gives total random values depending on the features that can be used further. And well, if you guys have any doubt, please comment down below and I'll be clearing it as soon as possible, and I'll give you solution for it, and I'll be putting the links for this code and the scikit-learn, not only for the export graph wizard, but also for decision tree classifier. And I hope you guys understood. Thank you so much. See you in the next video.